Hi, this is Wendy, and in this video series we'll look at selections or if statements. In this first video, we'll look at single and double-sided selections. In the next video, we'll learn about multi-selections and the switch statement. In the third video, we'll see how nested selections work. And in the last video, we'll look at some common errors programmers often make with selections and how to avoid them. In programming, it's common to have your code make decisions. For example, you might want your code to check the value of a circle's radius to make sure it's not 0 or negative so you can use it to calculate the circle's area. Or you might need to assign the shipping cost based on what province a shipment is going to. These kinds of things can be done with selection statements, which we also call if statements because they use the Java keyword if. A selection statement is one of a few logical program structures we use in programming. Besides selection, there is also a sequence and an iteration structure. The first basic logical structure is a sequence structure, which is a series of statements that execute sequentially. You've already learned how to write sequence structures. Every program you've written so far has actually been a sequence of statements executed one after the other. The second basic logical structure is the selection structure, which we use to make decisions. You can perform actions based on the result of a Boolean expression. For example, if a user input is valid, then perform some action, otherwise display an error message. The last basic logical structure is iteration or the loop, which allows us to repeat a set of statements some specific number of times or until a certain condition is met. We'll learn about the iteration structure after we've learned about the selection structure. Now there are three basic kinds of selection statements: the single-sided selection, the double-sided selection, and the multiple-sided selection or multi-select. The multi-sided selection will be covered in the next video. This video introduces you to the single-sided and double-sided selection. The single-sided selection is used when we have an action or set of actions to perform under a certain condition, but no action to perform otherwise. For example, if it's raining outside, take an umbrella. In this everyday example, the condition is it's raining outside. This will either be true, meaning it's raining, or false, meaning it's not raining. If the condition it's raining outside is true, then you perform the action take an umbrella. If the condition it's raining outside is false, then you do nothing. Here's another example. If the bill amount is over $100, give the customer a 10% discount. But either way, display the bill amount at the end. In this example, the condition is the bill amount is greater than 100. If this is true, we give the customer a 10% discount. But if the condition is false, we don't give any discount. But either way, whether there's a discount or not, we then display the final bill amount. To write a single-sided selection in Java code, we use the if statement, which has this general form. You can see that we have the word if, followed by a Boolean expression, and then a block of code that will execute if the Boolean expression is true. Boolean expression must be a valid Boolean expression that results in a Boolean value of true or false. Note that the word if is in all lowercase, and it's a Java keyword or a reserved word. Also note that the Boolean expression is enclosed inside parentheses, which are mandatory. You cannot leave off the parentheses. The code to execute the Boolean expression is true is enclosed inside braces or a code block. We often call this the if block or the body of the if statement. Note that, as always, we indent code that sits inside any code block. Let's try this one out. We'll write a program that asks the user for the customer's bill amount, and if the bill amount is more than $100, we'll give a 10% discount. If the bill amount is $100 or less, we won't give them any discount, but either way, we'll display the total amount owing. First, of course, we want to do our IPO chart. As always, we start with our output. Our output for this program is the final amount due. Now, what inputs do we need in order to produce that output? We need to know the bill amount. So we're going to have to ask the user to enter the bill amount. And then of course the next thing I want to do is determine what processing takes place to convert these inputs into that output. So first what I want to do is determine if there's a discount. So determine discount. And that would be based on whether the bill amount is greater than 100. If there is an actual discount, then I'm going to have to recalculate the final amount due as 10% of the bill amount. Now that we have the IPO chart, we can go ahead and code the program. So as always, to start off with, we need a scanner for user input. So I'll create one of those. And if you look back at your IPO chart, we have to make sure that we prompt the user to enter the input. So we're going to have to ask the user to enter the bill amount. And we'll have to retrieve that. Since that's a money value, monetary, there's going to be decimals, so this would be a double. There we go. So now that we've got our bill amount from the user, we now need to determine if we should be applying a discount or not. So this is where we're going to have our if statement. So I highly recommend when you do an if statement, after you type in the lowercase if, you know you're going to need a set of parentheses. So go ahead and open and close those. And you know you're going to need a set of braces. So open and close those. I highly recommend that you always open and close all your brackets and braces right away. You're going to start getting into programs now where you're going to have a lot of braces and a lot of brackets. It's going to be really easy to accidentally forget an opening or closing brace or bracket, and those kinds of errors are actually really hard to debug. So to make your life easier, again, I strongly recommend opening and closing everything and then going back and filling in the blanks, basically. So speaking of that, the next thing I want to do is I want to fill in the condition for my if. So I want some code to execute if the bill amount is more than 100. So my condition is going to be bill amount greater than 100. Even better, 100.0, because bill amount is a floating point number, so it would be more efficient to compare it to a floating point literal. Ideally, actually, this should be a constant. In fact, we can do that now as well. So I'll go ahead and create a public static final double, and I'll call it discount limit, because it's the limit for which we get a discount there, and then I can just use that here. It does make my code a bit more readable. There. And then inside my if statement, I now need to adjust bill amount with that 10% discount. So what I could do is I could just take bill amount and I'm going to reassign it itself minus 10% of itself. So itself minus, and to calculate 10%, I just take bill amount times 0.1. And that's fine, but there's actually a more efficient way that you could write this statement. If we just make it shorter and easier to read, make bill amount equal to B. So bill amount equals B minus B times 0.1. I'm just going to use brackets in here. You'll see why it's a little easier to read. Now, if you were to factor out B, right, then that would leave you with 1 minus 0.1. I hope I don't have to explain that too much. This is basic algebra from high school. So if I take B, or if I take both sides and divide by B, that's going to leave me with 1, and that's going to leave me with 0.1. So I factor out the B, and I get 1 minus 0.1, which is basically B times 0.9. So that means that I could rewrite this as bill amount equals bill amount times 0.9. That should make sense, because if I take off 10%, I'm keeping 90%. So I'm just saying 90% of the bill amount is what I want the user to pay. Now, I don't have to write it this way even. I could use an augmented assignment operator, and that's generally what I would do. Times equals 0.9. There we go. So this will calculate 10% off, or just basically set the bill amount to 90% of itself. Once that's done, I can then go ahead and display So total due. Don't forget your new line at the end. Like that. So if the user enters a value that is greater than 100, then I calculate 10% off. Obviously, I don't need to do it twice, so I'll comment that one out. So I calculate 10% off. I probably should make the 0.9 a constant as well. I'll do that behind the scenes. So I calculate 10% off. If the bill amount is not greater than 100, if, in other words, it's 100 or less, then it will skip this and it will just go right to the display. So we're going to save, compile, and execute. So I'm going to try it with something greater than 100. So I'll do 200 because it's nice and easy to calculate the answer in our head. So that is greater than 100. There we go. That is greater than 100. So it will take 10% off. That's $20. So it should display 180. There we go. It does. And then we'll have to try one that is less than 100. You don't need to compile again. Just execute it. It's already compiled. So if you enter 100, which is 100 or less, so 100 will work, it should just display 100. There you go. So again, bill amount, if it's 100, that is not greater than discount limit. So it shouldn't apply a discount, which is good. If you're not sure if you want to try an even lower number, you can do 50 and it should just display 50. Good. Now, one thing that's interesting about structures like if statements is that if the body of your if block contains only one line of code, you can actually leave off the braces. I'm going to get rid of all these comments. The comments don't count, but I'll take them out anyway, just for readability. And if the body of your if contains only one line of code, you can actually remove the braces. You don't necessarily have to put the blank line there. It is good practice. It's part of the standards document that you should have a blank line after the if. And then if I save, compile, and execute, it actually does the exact same thing. It doesn't change how the program works. It's just a different way of writing the same code. Now, I recommend actually leaving the braces on because it makes it prone to errors if you leave them off. If you come back later to modify your code by adding a statement or two to your if block, you might forget to put the braces back on. For example, have a look at this exercise. There's some code. I want you to just manually, by hand on paper or whatever, see if you can determine what you think the output will be, and then we'll try it and see if we get the same answer. So go ahead and pause the video. Again, by hand, see if you can determine the output, and then we'll check it and see if you're correct. So hopefully you had a chance to try and determine the answer. So if I was to keep track here, so we've got the variable number, and it's being initialized to a value of 5. The next statement, so again, usually just check off the ones that you've done. So the next statement, I want to know, is number greater than 5? So is this statement true or false? Well, number is currently 5. So we're basically asking if 5 is greater than 5. This obviously is going to be false because 5 is not greater than itself. It's equal to or less than or just equal to. So in this case, because it's false, you would assume, since it's false, it's going to skip down to the print line, and then if this area here is our output, it would print just 5. So maybe that's what you're thinking. So if we go and try this code out, I've already got it typed into my editor. I'm going to save, compile, and execute. And I see the actual output I get is not the output I expected. I actually get a 6 instead of a 5. The reason why we get a 6 instead of a 5 is actually because of the missing braces. Because the braces are missing, only this statement here is part of the if block. The number ++ is actually not part of the if block. It's actually just incorrectly indented. Because the if block has no braces, only the first statement under the if is actually inside the if block. Just because we indented number ++ does not make it part of the body of the if. If we were to actually indent it correctly, it would look like this, in which case it might be now obvious that since this is false, this statement is skipped because that's the body of the if, and then the program will move on with the rest of the code. And so it will execute number ++, which increments number to 6, and then 6 is printed on the screen, and that's why we get the number 6. If you wanted the number ++ to be part of the body of the if, then you would have to add braces. Like that. So if I add the braces, now it's clear to Java that both of these statements are part of the body of the if, and because this condition is false, it jumps to the closing brace and it prints number which never got incremented. It has a value of 5. If you make that change and then save, compile, execute, you'll see it does now in fact print 5. So that's something that you want to be really careful of. It's why I always recommend that if people are new to Java or just new to a language that has braces and semicolons, I always recommend that you go ahead and leave the braces on your if statements, and later you'll see other statements that use the braces as well. So go ahead and try this exercise on your own. Write a program that determines if a person has a body temperature above normal. When a person enters their temperature, determine if it's above 37.6 degrees. If it is, calculate and display the number of degrees above normal, so basically the difference between the user entered temperature and 37.6, and display you have a fever. You can see here there's some sample input with the required output. Don't forget to do the IPO chart for this exercise. Go ahead and pause the video, give the exercise a try, and then come back to check your answer. So as usual, I start with my outputs in my IPO chart. There's two things that I want to display. I want to display the difference between the user's temperature and 37.6. Sorry, that got messy. And I want to display the "you have a fever" message. And what input do I need in order to produce that output? Obviously, I need the user's temperature. And for processing, first, I need to determine if the user's temperature is above 37.6. So determine if user temp is greater than 37.6. And then I want to calculate the difference as the user temp minus 37.6. That will give me the difference. We're assuming that if we do get to the calculation part, user temp must be greater than, so you don't have to use a math.abs, because we know user temp is always going to be greater than if we get to the point of calculation. So now that we have our IPO chart, we can write the program. So here's the program solution. So I've created my scanner for user input, and then I retrieve the user's temperature. Except that I spelt that wrong. There we go. So I retrieve the user's temperature, and then I have to determine if the user's temperature is greater than the 37.6, which is normal. So does user have a temperature or not? Ooh, I just can't type today. I think I put my caps lock on. There we go. So my condition in my if statement is if temperature, user entered temperature, is greater than 37.6. If that's true, I go ahead and calculate the difference, and then I display the X degrees above normal, and you have a fever. So if I want to run this program, and for example, type in the sample was 38, then it displays 0.4 degrees above normal, and you have a fever. But if you want to execute it and try something below 37.6, like 37, you get no output at all. And that's the way it should work. Again, if this condition is false, the entire block of code is skipped, and in this case, nothing will happen. So that's why we don't get any output. So that's a single-sided if. A double-sided if has two actions or set of actions, and there's also a single condition. If the condition is true, one set of actions are performed, but if the condition is false, a different set of actions are performed. We often call a double-sided if an if-else statement. For example, you might decide that if there's $20 or more in your wallet, you'll order pizza. Otherwise, you'll make mac and cheese from a box. In this case, the condition is wallet amount greater than or equal to 20. If this is true, you order pizza. But if this isn't true, in other words, if it's false, then you make mac and cheese instead. Only one side's actions are performed. You either order pizza or you make mac and cheese. You don't do both. Here's the general form of the double-sided if. You'll see that we have if and then a Boolean expression in parentheses, and then a code block to execute if the condition is true, and then an else with another code block, and that code block we execute if the expression is false. Note that both the if and else are in lowercase, and they are Java keywords. Also note that there are now two blocks of code, the if block and the else block. The code bodies of both blocks need to be indented. The if block only executes if the condition or Boolean expression is true. The else block only executes if the condition or the Boolean expression is false. As an example, let's say that in our customer discount program, all customers get a 5% discount unless their amount due is more than $100, in which case they get the 10% discount. So here's the program that we wrote earlier. I actually added the extra discount constant, and I included for this version an extra basic discount constant with a value of 0.95, because if I'm offering a 5% discount, I'm basically keeping 95% of the bill amount. Again, it's just a little easier. So what I want to do here is I've already got the code that says if the bill amount is greater than 100, then apply the extra discount. But if it's not, in other words, else, then I want to take bill amount and I want to apply the basic discount. Like that. Again, if you're new to a program with braces, you probably want to open and close those braces right away. I've obviously been doing this for a while, although I still forget sometimes, so it's probably a good idea that I do the same thing, especially on the videos. So here we go. If my discount is greater than 100, then I use a 10% discount or keep 90%. Else, so if it's $100 or less, then it will use a basic discount of 5% or keep 95%. So I'm going to save, compile, and execute. And again, we'll test it out. So I'll test it out with 200. It should still give me 180, which it does. And I'm going to execute again. And when I try it with 100, so it'll take off 5%. So that should give me $95. There it is. Cool. Now, as with the single-sided if your if or your else block, has only one line of code, it is permissible to leave off the braces. This is perfectly fine, but again, as I mentioned before, it is a good idea to leave the braces on, just in case you come back to edit your code later. If you add statements, you might forget to put the braces back on. For example, try this exercise. See if you can manually determine the output of this segment of code. Again, pause the video, give it a try, and then come back and check your answer, and we'll actually run it here so that you can see. So hopefully you had a chance to give this a try. Again, I'm going to trace through it just like we did before. So I'm going to take my variable number. This time, it's being initialized to a value of 6. When I go to my next statement, my if statement, and I want to evaluate, is number greater than 5? In this case, number is 6, which is in fact greater than 5. So this would actually be true, which means we're going to do this print line. If this is my output over here, it's going to take the current value of number and display it. 6, good. And since this was true, it skips the else, so we don't do the else at all. And then we figure, okay, we'll go to the next line of code after the whole if else, and that's print line number. Well, number hasn't changed, it's still 6. So we would imagine that the output of this program would be 6 on one line and then 6 on the next line. If we run it to see if we're correct or not, you're going to find that, of course, we're not correct. When I save, compile, and run this code segment, we see that we instead get the output 6 and then 7. And it's for the exact same reason that we had this problem in the previous program. In this program, when we look at the else block, the number ++ is actually not part of the body of the else. The body of the else, there's no braces, which means only the print line statement not greater than symbol 5. That's the only statement that's actually in the body of the else. Once again, number ++ is simply not indented correctly. So when we perform the code in the if block and then skip over the else block, we continue with the rest of the program, which is to increment number to 7, and then it prints 7, and that's why we get the value 7 on the screen. Again, if you want to make sure that number ++ is in fact part of the else block, then you would have to put braces around your else. I would in fact also put braces around the if, but you don't have to. But again, I always recommend, especially to new students, I always recommend that you always put the braces on, even when you don't need them. But there's the output 6 and 6, and that's because I put number ++ inside the else block. Let's do another programming exercise. The cost of shipping a package is determined by whether or not the package is going to a local address. The user will enter the weight of the package and whether or not the package is local. The shipping cost is 25 cents per kilogram for local packages and 35 cents per kilogram for non-local packages. The program should display the total cost of shipping the package. When it comes to input for the local or non-local value, you can handle this however you like. You can use a string input or a char input, or you can even use a numeric input, 1 for local, 2 for non-local. I actually just like to ask the user a yes-no kind of question, such as, is this package local, or is the address local? And then prompt them to enter a yes or no answer, and I only capture the first letter of the input as a char. It's just easier and a little bit more efficient in some cases, but do whatever you're comfortable with. Go ahead and pause the video. Don't forget the IPO chart. And then when you're done, come back and check your answer. So hopefully you had a chance to try this exercise. Let's do the IPO chart. As usual, we start with our output. Pretty much the only output to this program is the total cost of shipping the package. So total cost of shipping. What do we need from the user in order to determine the total cost of shipping? First, we need to know the weight of the package. And we also need to know, is it local or not local? So we're going to have to ask them those two things. And then how do we transform these inputs into this output? So the first thing we need to do is we need to determine the cost per kilogram. So to determine the cost per kilogram, I don't know if you can hear the dog barking upstairs, not my dog. We know the cost per kilogram is 25 cents per kilogram if it's local, and 35 cents per kilogram if it's not local. And then once we've determined the cost per kilogram, we can calculate the total cost as the cost per kilogram, times the weight. Now that we have the IPO chart, we can write the program. So I've gone ahead and started the program. I've created two constants, one for the cost of shipping locally and one for the cost of shipping not local. I've gone ahead and created my scanner and I've asked the user for the weight, and I just asked, is it a local address, yes or no? And that way I'm just going to grab a char local as either an uppercase Y or anything else. I'll assume if it's not an uppercase Y, they mean no. It just makes my life and yours a lot easier. So what's left to do is I now have to determine the cost per kilogram. So there's a couple of ways you can do this. Obviously, we're using a double-sided if, but the best way to do this is to take a variable and simply use your if statement to assign the correct value to that variable. I'll show you what I mean. I'm going to create a double variable called cost per kilogram, and I'm going to initialize it to 0. There's actually another way you can do this without the double-sided if, but obviously that would be kind of pointless. So we'll do it with the double-sided if first, and then I'll show you the other way. So I'm going to start off with if. So if, and then again, put all your brackets and braces. In fact, you know this is going to be an if else. So if you want to put the whole kit and caboodle in there, that's actually a great idea. So in the if condition, this is the condition under which, and you can do this either way, but I'm going to say the condition under which it's local. So I know it's local, this is why I used a char, if the local variable contains an uppercase Y. Again, I let the user type in yes or no or whatever, and I grabbed only the first letter. I'm going to assume if it starts with an uppercase Y, that's a yes, and that everything else is a no. So if it's equal to an uppercase Y, it's local. And then what I'm going to do is cost per kilogram, I'm going to assign it the local cost constant. And then in the else block, this would execute if it's not local. So if the user entered something that didn't start with a Y, I'm assuming that's not local, in which case cost per kilogram is equal to non-local cost. Like that. And then after my if statement, this is where I want to calculate and display. So I want to calculate my total cost. So double total cost equals the weight times the cost per kilogram. So the reason why I did the calculation this way, if instead you took the weight times, you would need cost per kilogram, but if instead you took the weight times 0.25 or 0.35, if you stuck it in here instead, you know, total equals weight times 0.25, and then total equals weight times 0.35, that calculation becomes redundant. If someone said, oh, we've changed the formula for calculating the total cost, then you would have to edit 2 lines of code. And then in the future, they might have other criteria, local, not local, out of country, you know, across the ocean, whatever. There might be additional criteria. So then you'd have more statements to edit if your formula changed. So we want to try and think ahead to how can we make this program easier to modify in the future. So that's why you don't want to have redundant code inside your if and else blocks. We instead all we're doing is looking for the value of the cost per kilogram. That's all. So you shouldn't be calculating in here. The whole point of the if else is to only find the cost. That's it. The total cost we can calculate later, and that's how we should do it. Same with the output. Some people, I've seen students where they do the calculation and the output statement, it's exactly the same, and they put it in both the if and the else block. That's really redundant. We don't want to do that because, again, it's harder to modify later, or it's more work to modify, really. And it's more prone to error. You might forget to modify one occurrence of something. That happens all the time. So I'm going to do my calculation and my output after the if statements. There we go. So I grab the input from the user, and then I determine the cost per kilogram, and then I use the cost per kilogram to calculate my total cost. So if I save, compile, execute, we can test it out. Except that I've got an error because I spelled cost per kilogram with an uppercase or lowercase k. That's all right, that happens. And now we can save, compile, execute. So I'll enter something we can do in our head. So I'll enter, say the package weight is 10. So if I choose local, so I'm going to say yes. Notice it doesn't matter. I could type yeah if I wanted to. It's just capturing the Y, and it'll take whatever I type that starts with a Y, it'll convert it to uppercase. So I can type whatever I like as long as it starts with the letter Y. So that should calculate a total cost. It should use the 0.25 because I said yes, it's local. So it should come up to, there we go, $2.50. If I do the exact same input but for the weight, but this time I'll say local no, or you could actually type anything that does not start with a Y. I could type apple and it would consider that a no, but obviously most users won't do that. So I'll say no, or even just the letter N is fine. And it calculates $3.50 because it's 35 cents per kilogram. There you go. Here's one more exercise for you to try. Write a program that determines whether a year entered by the user is a leap year or not. A leap year is any year that is evenly divisible by 4 but not 100, or that's evenly divisible by 400. For example, 2016, 2000, and 2020 are leap years, but 2018 and 1800 are not leap years. Go ahead and try this exercise on your own. Don't forget to fill in the IPO chart. Pause the video, and then come back when you're done and check your answer. So hopefully you had a chance to try this exercise, and we're going to take it up really quickly. So as usual, IPO chart we start with first. So what's the output to this program? We want to know if it's a leap year or not. So is the year a leap year or not? That's all we want to know. What input do we need? Well, we need the year. What year are we asking if it's a leap year or not? And the processing. Here comes the fun stuff. So, if we look at our description, a leap year is any year that is evenly divisible by 4. So we'll just stop there for a second. When we want to know if something's evenly divisible, we know that's modulus. So we're going to end up with year modulus 4. If it's equal to 0, then that means the year is evenly divisible by 4. The next one is not 100. In other words, evenly divisible or not evenly divisible by 100. So again, year modulus 100 if it's not evenly divisible, so not equal to 0. And then the other one is if it's evenly divisible by 400. So year modulus 400 equals 0. So the next thing is, how do we take these three conditions and put them together? So in the first part, it says evenly divisible by 4, but not 100. That seems to imply an and, because it has to be evenly divisible by 4 and not evenly divisible by 100. That's why you get years like 1800 are not a leap year, because even though 1800 is divisible by 4, it's also evenly divisible by 100. And it has to be evenly divisible by 4 and not evenly divisible by 100. So that's why 1800 ends up not being a leap year. So this needs to be an and to join these first two together. They're going to be joined with an and. The last part says, or it's evenly divisible by 400. So that means either this set of conditions is true or this condition is true. So this is then going to join to this last one with an or. So that means our processing to determine if a year is a leap year is going to be year modulus 4 is equal to 0 and year modulus 100 is not equal to 0, or year modulus 400 is equal to 0. This is actually a standard Boolean expression that determines if a year is a leap year or not. If you look in your textbook, this actually is in your textbook somewhere in chapter 3. I can't remember exactly where, but it's in there. So now that we have the IPO chart, let's check the solution for the program itself. So here's the solution I came up with. As usual, I construct a scanner, and then I grab the year as an integer. Nobody's going to enter a fraction of a year. That just doesn't make sense. So I grab the year as an integer, and then I write the if statement that determines if it's a leap year or not. Again, I try to eliminate as much redundant code as possible. You might have gone ahead and printed your output right inside the if and then the else, but here's how I did it. So this is my big condition. We saw that in the IPO chart. If this evaluates to true, I actually have a variable that I had declared and accidentally deleted, so I'll just do that really quick. Year equals null string. So I had a variable, leap year, and if it is a leap year, I just give it the word is. And then if this is false, it means it's not a leap year, so I actually give it is not. And then what I did was I just did a format specifier for the is or is not right there with a space around it, because I didn't put spaces inside the string around the outsides. So this is the year, so it'll say %d, and then either is or is not a leap year. See, I'm lazy. I try to come up with the best way to have as little coding, as little typing as possible. So there you go. And that's actually nice and modular as well. So year goes in the %d, and then this is or is not string goes in the %s. If we try it out, I'm going to save, compile, and execute. So as we know, 2020 was a leap year, so if I type in 2020, it says 2020 is a leap year. And if I execute it again, if I try 2000, 2000 is a leap year. It's not because it's evenly divisible by 4 but not 100, that's obviously false, but it's because it is evenly divisible by 400. So there you go. And then if I try 1800, it'll say false because it is evenly divisible by 4, but it's also evenly divisible by 100, which isn't allowed. So there you go. 1800 is not a leap year. There we go. So that's it for single and double-sided selections. In the next video, you'll learn about multi-sided selections, which allow you to have several conditions, each of which has their own set of actions. I'll see you over there. Thanks for watching.